Okay, so I'm going to show you how to use transformations to graph this function. So here's an example where I'm using a horizontal shift and a compression or stretch. Okay, so how can you show? Well, this is one way of doing it. Now you could do it with the points and then you realize where the points move and how they're affected, like I've done before. But you can also graph each piece, like build the function here using the parent function. So the parent function here is just, let's call it g of x equal to log x, right? So it's common log. And so we know that this is going to be, behave, how is this going to behave? Well, it's going to go through 1, 0, right? So it's going to go through 1, 0. And it's going to go through, what else? It's going to go through 1, 0. It's going to go through 10, 1. Right? Because remember, it's the b is 10. Okay, so this is going to go, I'm going to increase this out here a little bit more. Or a lot more. So that's about right there. And then it's going to go through 1/10, -1. So probably right about there. Okay, so this is looking something like this. Okay, so there's our parent function, g of x. Okay, now let's do the first transformation. So let's do the shift, right? So let's do the vertical shift. And so let's call that h of x. So h of x is equal to log x plus 2. So it's going to be a shift to the left 2 units, right? So that means we're going to shift these points to the left. And also the vertical asymptote, remember, is at x equals 0, so that's going to be shifted to the left 2 units as well. So let's plot that. So it's going to be at -2. Okay, so there's our asymptote. And now we're going to move all these points to the left. So this is going to go from 1/10 is going to move over to -1, -1 and 9/10. So about right there, right? And then this is going to shift over 2 units from 1 to -1. And then 10 is going to shift over 2 units to 8. So this is going to go to here. Right? And so now this one goes like this. Okay, so now there's h of x, right? Here's h of x. And then finally, now what do? Now we multiply by 5. So now we're going to multiply all of the y values by 5. So again, we take the points. Okay, so what are the 3 points? The 3 points is what? Well, now it's at here, so it's at -1 and 1/10, right? -1, or excuse me, 9/10, right? 9/10, -1 and 9/10. right? So that's going to be 19 tenths. Okay? So I wrote it as an improper fraction for a reason. It'll be easier to work with as far as multiplication here, for me anyway. And so this is going to be -1. Right, so that's 1 point. And then the other point is going to be -1, 0. And the third point is 8, 1. Okay, so that's here, h. Now, we're going to multiply all of the y values by 5. That's what we're doing here. So this point is going to go to -19 tenths, comma -5. This is going to stay the same. And this is going to go to 8, 5. And so now when we plot those points, what do we get? This is going to stay the same. Oh, so we don't need that. So we can actually leave that the same because it's unaffected. So this is going to be -1 and 9 tenths. -1 and 9 tenths. Okay, so we didn't need the transfer. So I missed, never mind. So now, so what's going to happen here? This is going to go to where? This is going to go to -5. Right? So this is going to go to -5. So this is going to go down here to about here. Okay? And then this is going to stay the same right here. And then this is going to go to 8, 5. So this is going to go up to here. Right? So this is going to go right about there. So now if I connect these, what's going to happen? Now watch happens. This is going to go something like this. And it makes sense because it's a vertical stretch, right? And so now this is our final answer. Right here. This is our final graph. Now, could I have done it from the get-go from just using the transformations on these 3 points and then moving the points and then just doing the curve like I have done before? Yes, and you can do that. Okay, but also this is good because it shows the actual progress of the transformation. Okay, so on an exam situation, you could do it this way and plot the points. Okay, if you do it this way, where you just use the 3 common points, right, which are what? The basic function for this one is what? It's going to be 10, 1. 1, 0, and 1/10, -1. Okay, so if you know those 3 points, right, for the basic parent function, then you could use the transformations on those points and get the same points. But again, you have this option here to do as well. Okay, on an exam situation, I would probably do it this way because it makes it clear that you're using transformations. Okay. And it's probably good for practice. Okay, have a great day.